Here I have loaded the now familiar Davidson County tutorial dataset in LP360 standalone to demonstrate the export utility. To begin, we're just going to simply select the Export Wizard tool on the main LP360 toolbar. You should be able to work through most of this on your own, just referring to the slides earlier in this presentation. I'll just point out a few highlights. Notice that if you select the source points, and this is available whether you're exporting a surface or a points, that you have all of the normal filter options available. If you choose to export points, you have a number of different formats available. If you select LAS, you can choose version. Because LAS does export the coordinate system as part of the header, you can choose your output coordinate system. If you choose surface, the entire interface changes. Again, you should be able to work through most of these options on your own. You have the choice to select a surface method. For most purposes, the ideal surface is a tin, but this really depends on what the end product is going to be. And there are some other special uses for point insertion that we'll talk about later. Break line enforcement, remember we talked about the difference between a DEM and a DTM. Break line enforcement allows you to bring in 3D break lines and use that as part of the interpolation for the final product. You have a variety of export formats, and you can choose to export a number of different products. And for many of those products, as you add them, you see tabs that allow you to set the properties for those products. The one option that is usually the least intuitive for people is the elevation difference. Again, this is what you can use to produce a height model or a normalized difference surface model. You would initially select your surface, for example, to be ground points. So I would go in and just say I'm going to export only class 2 to be my initial export surface. And that's what I'll get in the elevation raster. But then I can say, if I want an elevation difference surface, I can set the top layer, which I might set to be all the first returns. And then when I export, I will get a difference between the first return layer and the ground layer. Next, we'll select the extent of the export. Since this is a very, very large data set, I'm going to just select a small area for this demo. I'm going to draw the window in the map. I click on Draw Window Tool. It allows me to select a small area. And now I can click Next. And I'm going to designate the path for the output file. Notice that an extension has been added automatically based on the file format that I chose, which was binary raster, so it got a .flt extension. And now I just go ahead and click Finish. When the process is complete, you'll receive a message, and the data in this case was loaded directly to the project. I can zoom to that layer and notice that I have white represent higher elevations or higher values, higher heights, and black represent lower heights. I could also open this FLT binary raster result in ArcGIS, in which case I would see the height ranges displayed in the elevation legend. Here I've loaded the two FLT results into ArcGIS, and you can see first the bare earth DEM, where the elevations range from 558 to 745 feet. I've displayed that with a common elevation legend. Let's look at the difference model. This is, remember, the height of the first returns subtracting the ground, so we're getting the height of objects, and we see that we have elevations ranging from about 142 feet, which makes sense for maybe some tall buildings, down to negative almost 10 feet. It may not intuitively make sense right away that there might be some negative elevations because the first returns should never be below the ground. Usually you get these negative elevations right along the edges, and it's just an interpolation artifact.